Let's now see how to configure GLBP, the Gateway Load Balancing Protocol. What we want to do is set up R1 and R2 in this topology to run GLBP. They're going to be members of the same GLBP group. On router R1, I'm going to go into Interface, Fast Ethernet 0/0, and this is somewhat similar to setting up HSRP. After all, GLBP, like HSRP, is Cisco proprietary. We're going to say GLBP, and we're going to give a GLBP group number, much like HSRP, and VRRP group 10, and we specify the virtual IP address by saying IP 10.1.1.1. And you can see some of the other options from context-sensitive help that we can give for a GLBP group. For example, we can set the priority. The default priority is 100, and if I want this to be my AVG, my active virtual gateway for this GLBP group, then I want it to have a higher priority than the other router. And to set this up, I'll say GLBP group 10 priority 110. And like HSRP and unlike VRRP, preemption is not enabled by default. I'll configure preemption, which says that this router can take over as the AVG if it has the highest priority in the group currently. And I'll say GLBP, group number 10, preempt. And one of the great things about GLBP is it allows us to load balance across multiple AVFs, active virtual forwarders. And there are different load balancing algorithms that we can use. Let's use some context-sensitive help to see what's available. Let's do GLBP group number 10 load balancing, and we could choose an active virtual forwarder based on the source MAC address. We could do round robin, and that's the default, by the way, where we pick one AVF, then we pick the next AVF and the next, and so on and so on. We just loop around in a round robin fashion. Or we could get really advanced and assign different weightings to different AVFs. Maybe we want the virtual MAC address of R1 in this topology to be handed out to 75% of the hosts, and we want router R2's virtual MAC address to be handed out to the other 25% of the hosts. We could do that. In this case, we'll just keep it simple. We'll leave it at the default, which is, again, round robin. And we're done with our configuration on R1. Let's go to R2. On R2, we'll give a similar configuration, except I'll leave the priority at the default of 100. On R2, I'll go into Interface Fast Ethernet 0/0, and we'll say GLBP group number 10 as a virtual IP address of 10.1.1.1, GLBP group number 10 preemption, because that's not enabled by default. And now, router R2 should become an active router. And when I say active, I mean it's going to be active for its virtual MAC address. And it's going to be in listening mode for router R1's virtual MAC address, and vice versa. Let me show you what I mean. I can say show GLBP brief, and we can see the first line in the output where we have a priority listing. This is referring to the group's AVG, the active virtual gateway. The AVG, that's the router that's responsible for handing out the virtual MAC addresses, and that's the router that's responsible for responding to ARP requests coming from our hosts on a subnet. Right now, we're in standby to become the AVG, but we're active for this virtual MAC address. Router R1 is active for this other virtual MAC address. Let's go to R1 and prove that. On router R1, we'll do a show GLBP brief command, and you see that we are active as the AVG. We are actively forwarding traffic destined for this MAC address, and we're in listening mode. We're kind of standing by to take over the servicing of this other virtual MAC address. Router R2 is currently active for that MAC address. So what does this look like from the perspective of our PCs? Well, let's go to PC 1, and let's do a ping to 1.1.1.1. Can we get there? Yes, we can. Let's do a show ARP to see what MAC address is associated with 10.1.1.1. And you see here's the MAC address that we learned from our AVG. Notice it ends in a 01. Let's go to PC2 and do the same thing. From PC2, let's ping 1.1.1.1. Success. Let's do a show ARP. And look at this. Same IP address, 10.1.1.1, but different MAC address. That's the magic behind GLBP. GLBP handed out different MAC addresses for the same IP address in response to ARP queries from PC1 and PC2. That's how GLBP makes load balancing so easy to set up. But remember, GLBP does not just give us load balancing, it also provides us redundancy like HSRP or VRRP. Let's prove it. Let's go into router R2, and we'll go into interface fast Ethernet 0/0, and let's shut it down. When we do that, we'll see that router R1 is going to become the active router. In other words, it's going to become the AVF, the active virtual forwarder for this other MAC address. You see, we had been in the listening state. Now, if I do a show GLBP brief, you see that we are actively forwarding traffic for both of these virtual MAC addresses. That's a GLBP providing redundancy for us. Here's another verification command for you. Instead of saying show GLBP brief, we could say show GLBP. We get some additional information this way. Let's take a look at the output. Notice that here on router R1, we are active for group 10, meaning we're the AVG, we're the active virtual gateway. Also notice that like HSRP, we have a default hello time of 3 seconds, and we have a default hold time of 10 seconds. And we also have some additional timers with the GLBP. The redirect timer, notice it's set to 600 seconds or 10 minutes. What is this timer doing for us? Well, the redirect timer says how long the AVG is going to respond to ARP queries with the virtual MAC address of an AVF that has failed. So R2 has failed as an AVF. However, we're going to still hand out the virtual MAC address that was assigned to router R2 for a period of time, and by default that period of time is 10 minutes. We've got another timer, the forwarder timeout time. It defaults to 14,400 seconds, which is 4 hours. This timer is saying how long the backup AVF, R1 in this case, is going to accept frames that are destined for the virtual MAC address of the AVF that failed. Hopefully after a fairly short period of time, those devices pointing to 10.1.1.1 as the default gateway, hopefully they're going to send out another ARP and be given another virtual MAC address so we don't have to continually service the virtual MAC address of the failed AVF. But we will for a while in anticipation that the failed AVF is going to come back online. And we had a couple of AVFs, active virtual forwarders, that belong to this group, and we see that represented here, forwarder 1. We're currently active as the AVF for forwarder 1, which has this virtual MAC address. And because we shut down that interface on R2, we're the active router for the other active virtual forwarder, servicing this other virtual MAC address. And like I mentioned earlier, we could get even more advanced with the GLBP. I could play with these weightings to send one virtual MAC address more than another virtual MAC address in response to ARP queries. But here we just did a basic round-robin load balancing, which is the default, which allowed PC1 to get one of our virtual MAC addresses and PC2 to get the other virtual MAC address. And that's an overview of how we configure and verify gateway load balancing protocol.